Everyone, and welcome to my YouTube channel. So here today we are going to be looking at a paper which is our CS110 for 2025. So we are going to look at the full paper. So if you want more content like this, kindly like, subscribe and share for more so that you can even encourage me to make more content like this. Let us make all these courses a walk in the park. So let us begin. So we are going to do all these questions. Now let us begin. So the question says, consider Ms. Polepole a CBU student who has already acquired a monitor, a mouse, and a computer casing for her desktop setup in a residence hall. However, to make the computer fully functional, she needs to install the core internal components inside the casing. Help Ms. Polepole complete the system unit by listing 6 major components without which the computer would not work, which must be purchased from the computer hardware store and installed inside the casing. For each component, write the name of the component and the typical or recommended specification that for that component. You can include the specification, you can include the capacity, the type or the size, etc. Let us begin. So number 1, we have the motherboard, which is the circuit board where items are plugged in, or rather where items are inserted. So we have the motherboard. So the specification that we might have on the motherboard, we can have the ATX form factor, or we can have the ATX form factor, or we can have the micro ATX. So what is this? So we can have the ATX micro form factor, or we can just have the ATX form factor. So what is this form factor? We are just simply talking about the shape of the motherboard. So let me show you an image. So this is what we mean. So the standard ATX, which you can just put ATX, is just the shape of the motherboard, like how you see something like this. Or we could have the micro ATX. This is smaller, meaning to say it has got less number of slots. The number of slots are more like the positions where you can plug things and all that. So now this will be able to determine how fast your computer will be able to perform. So the bigger the form factor, the more faster your computer will be able to perform, because it has got a lot of slots where you can more like insert certain components that are responsible for running the computer and all that. So this is the motherboard. The motherboard can be like that. So that is what we mean by that. The second thing that Ms. Polepole needs is, so number 2, one of the most important thing is the central processing unit, which is abbreviated as CPU. So remember, the instruction is that we should not be writing in shortcuts, so write the word in full like that. So now the central processing unit, which is mainly made up of the central unit and also the arithmetic unit and registers. So now let's have an image for this. So this is the CPU, which is mainly what we call the brain of the computer. So now for the specification, we could have at least Intel Core i5 10th gen and above. So this is what we mean. We could have at least Core i5 for better performance, Core i5 going up, Core i7 or the Core i9. So we can say Core i5 and above. So it should be Intel Core i5 and above. Also, it should be 10th generation, 10th gen and above. That's number 2. So remember, just by writing the central processing unit, that means to say you have included the arithmetic logic unit and you have also included the central unit. So there is no need for you to also mention the arithmetic logic unit after writing your central processing unit. Let's look at our third one. We could also have the random access memory. This random access memory is used to temporarily store information for running programs. This is very important as you are running your program. So you find that the computers, when you're running a computer, there are files that, let's say, when you have used them, they begin working on the background. For example, we could have these files that are running here. So this is able to, more like you are able to see all these because of the concept of RAM. RAM is able to store whatever is working in the background. This also helps the computer to perform very fast in terms of how fast it will be able to execute certain things. So this is very important as it keeps as it stores temporarily memory used to run programs. So the specification for this, we could have something like 8 GB. So maybe you have heard of 8 GB of RAM, 8 GB and above for a faster working computer like that. So that is what we might have on RAM. So we have looked at our number 3. Our number 4, what we could have is storage. So the storage device that we are going to be using, is it perhaps, so the storage has to be either solid state drive, also known as SSD, or we can be using the hard disk drive, which is HDD like that. So this is what we have. So the specification, if SSD is usually very fast, so for SSD you can use at least 256 SSD. Then for HDD you can use at least 500 HDD. So now the reason why I have taken a value that is small for SSD is simply because SSD is very expensive. So she can at least get 256 SSD, meaning to say 256 and above. Then for HDD, she can get at least a 500 GB so that it's a bit faster. The less the amount of space for HDD especially, the slower it is. The slower the computer is. So she has to get something that is reasonably big. So these are the storages that we have. The HDD, which is able to, more like it is able to rotate like that. It is made up of moving parts, therefore it is slower as compared to the solid state drive, which is just stationary like that. So for this one you really need a lot in order for the computer to be fast. But on the other hand, this one, since it does not even move, it is very expensive. So that's why we need a smaller value like that. So let's look at another one. Number 5, we could have the power supply unit. So the power supply unit, the PSU, is responsible for more like powering the internal parts of the computer. So this is very, very important. The specifications that we might have for this one is at least we might have power such as 500 watts to 600 watts to power the internal parts of the computer. So this is our power supply unit. So this power supply unit is responsible, so as we see everything here, it is responsible for empowering the internal parts of the computer. So it's very, very important. Don't forget the specification, at least 500 to 600 watts, like that. So let's look at our last components that is very, very important. Another very important component that we need is a graphics card. So the graphics card is also known as the GPU, which is the graphics processing unit. So this component is very, very important. Just as the name entails, it is responsible for, number 1, processing and also displaying images. So now, to answer this question, you just write the yellow, the letters in yellow, the graphics card, which is the GPU, which is the graphics processing unit. So this is there to just help you understand. It is important for, number 1, processing and displaying images, animations on the monitor, like that. So do not write that, just write the GPU, which is the graphics processing unit. So this word is processing unit. For this one, we could have specifications such as 4 GB VRAM. VRAM simply means to say, we have the V means video, and we know what RAM is. So we could have that for the graphics card. It could be 4 VRAM. So that is the specification. So we can have the graphics card with an heatsink like that. So this is our graphics card like that. So this is responsible for the animations, or rather the images. As long as there are images on the computer, the graphics card is very, very important. So this is what we are talking about. So it's very, very important. We have the GPU, we have the video memory. In that case, the specification we said was at least a 4 GB VRAM, like that. Let's look at, so we are done with that question. Let's look at our next problem. So our question 2 says that we have the dash refers to the number of times per second the screen is redrawn, measured in hertz, and is especially important for smooth video playback and gaming. So that is the definition of what we call the refresh rate. So for the first one, we are going to call this one the refresh rate. So this is the refresh rate. Let's get more into detail. Let's look at our definition again. So the dash refers to the number of times per second the screen is redrawn, measured in hertz, and is especially important for smooth video playback and gaming. So as you can see, there should be smooth video playing and gaming. So as you can see, let's say we have this refresh rate. We could have 60 hertz, 90 hertz, we could have 120 hertz. So as you can see, the lower the refresh rate, the slower, more like some images are still showing. You can even see this from, let's say you are doing a selfie picture, you have moved your hand but it's taking long, especially if you're doing a video call on WhatsApp. That is what we call refresh rate, how smooth something looks, or how smooth or how many times the screen is redrawn per second. Refresh rate is very, very important for you to get a clear video or image. As we can see, for this one, it has got a high refresh rate, meaning to say you can see at every second, you can see the position of the hand where it is. But if the refresh rate is low, like for this other one, you can see that there are more like after images where the hand should be like that. So this affects more like the clarity. So this is what mainly what refresh rate is. So the number of times the screen is redrawn per second measured in hertz. Let's move on to our next part. It says that the dash is the distance between two pixels of the same color and affects the sharpness of the image. A smaller value means a clearer display. Another important specification, okay, just here, the dash is the distance between two pixels of the same color. So as long as we are looking at 2 pixels of the same color, this is what we call dot pitch. So this is what we call dot pitch. So for the second part, we are going to be looking at the term which is our dot pitch. Let's get into it. So as long as we have something like this, so the dot pitch is the distance between 2 pixels of the same color. So if we have these colors, we could have a pixel, these 3 colors, which are more like forming that. But the distance between 2 pixels of the same color, so we have red and red, that is what we call the dot pitch. We could have another image like this. So this distance from one blue color to the other blue color, we are going to call it the dot pitch, like that. So that is the dot pitch, which is simply defined by. For the next part, it says that we have another important specification. Okay, first, the dot pitch is the distance between 2 pixels of the same color and affects the sharpness of the image. A smaller value means a clearer image, which or should I say display, which makes sense because the more closer to color, to more like 2 pixels are to each other, the more clear you'll be able to see the image, because more like colors are close together, therefore they are able to produce a very contrasting image. Now for this other one, it says that another important specification is the dash, which indicates the number of pixels displayed horizontally and vertically. For example, 1920 by 1080, and determines how much content can be shown on the screen. So immediately you see values such as these. So when we are looking at the number of pixels displayed horizontally and vertically, this is what we are going now to call resolution, and determines how much content can be on the screen. So this is what we call resolution. So this is what we mean by resolution. So as you can see, we have numbers such as 144p, 1080p, we could have 4K. Now as you can see, the amount of content shown on 144 is very small. It's not as clear as compared to this one. This one, you can even see some of the ribs. But as we increase the resolution, you will find that the image becomes more and more clear, like that. You can see this skeleton. So this is the resolution. It shows you how much content can be displayed on the screen as per definition. We could have also this one, the clarity. Even as you are watching things like anime, you will find that the more you download a lower resolution, the more unclear the images are. So this is what we simply refer to as resolution. So as you increase your resolution, even more content of the item is able to show. So even 4K, which is the greatest among these qualities, you will see that the box will be made more and more clear. So this is what we call resolution. It is given by these numbers. So these numbers are the n numbers that we had. So this one is 1020, the one on the middle, by this 1080. So this is what we call resolution. So we can have a whole number of examples. So this one is unclear. As we increase the resolution, the more you can even see the face forming like that. So you can have something like this, and you can have the 4K image, which can be looking like a normal guy like that. So that is basically what resolution is. It simply shows you the amount of content that can be displayed on the screen. The other one is saying that the dash is the diagonal measurement of the screen, typically measured in inches, and influences how large the display appears to the user. Modern monitors often use dash technology. So we are here. The dash is the diagonal measurement of the screen, typically measured in inches, and influences how large the display appears to the user. So this one is what we call the screen size. So the screen size is the diagonal measurement of the screen, like that. So the diagonal measurement of the screen is what we refer to as screen size, like that. So that's the screen size. So let's have an image for this. So this is what we refer to as screen size. So the screen size in math, we can just say it's the hypotenuse. So the distance, the diagonal distance from here up to here is what we call screen size. So when you hear the word 55 inch, they are simply referring to this distance, the diagonal distance from one corner to the other. 12.1 inches diagonal distance, 12.1. 13.3 is the diagonal distance. So this is found by our finding the hypotenuse of 11.3 and by 7.1. If you do your math, you will find this value. So this is what we refer to as the screen size, which is the diagonal distance, which is shown as the display on the person's screen, like that. So just as we have, the dash is the diagonal measurement of the screen, typically measured in inches, and influences how large the display appears to the user. For this other one, we have the last one. The modern monitors often use dash technology, which provides better brightness, contrast, and energy efficiency compared to other types like LCD and CRT. So CRT, which is the cathode ray tube, and LCD, which has gradually been stopped using. So we have the number 5, the one that is mostly used now, is the light emitting diode. Light emitting diode, which is known as LED. So let's compare the two. So let's take the same image. We have LED and LCD. So LED, which is our light emitting diode, for this one you will find that the image is the same, but the clarity of the image is different. As you can see, even the way the cursor is looking, it's more clear, even the car, as compared to this one, the LCD. So this one is providing more clarity, and even the tree, even the brightness is far much better as compared to that. Even the tar rod, you can see the distinction. So this is LED, which is the new technology that has been used lately for making TVs, unlike the CRT and the LCD. The CRT, which is the cathode ray. So just in case you didn't know, this is the CRT TV, known by that. So having a hind head, or rather a forehead, like that. So this is the cathode array or tube, which is our CRT. So this has recently not been used. The one that is used is the LED mostly. Let's move on to our next problem. So for this other one, it says that carefully examine the following sentences and identify which type of memory is being referred to. So the first one, the type of memory is the fastest and smallest, located directly within the processor, and it holds instructions and data currently being executed, often for only a few cycles. So this type of memory is what we call registers. So registers are the fastest type of memory. So let's look at the computer memory hierarchy. So as we can see, as we go up, we are from low with access speed increasing like that. So we have the hard disk with the lowest access time. We have the RAM, then we have the cache memory, then we have the registers. So this is increasing order as we go up, increasing order of access time. So information is easily accessed between these. So from hard drive, so as you can see, these are big. As we move from hard drive is even bigger in terms of the size of the hard drive is bigger as compared to RAM. RAM is bigger than cache. Cache is bigger than the registers like that. So the concept of memory is how small is the room. For example, if we are looking at, let's say we have the hardware like that, then we have the register like that. So in here, if you are looking for something that is here, it will be very, very easy for you to find it. But here on the other hand, if you are looking for something like this, it will be very difficult for you to find it. Same size of the thing you are looking for, but because the room is big, it will be very, very difficult for you to find it. So you can think of the room as having more like compartments. So you will find that on one room, it will have more like many rooms because it's big. So as a result, it will be very difficult for us to more like find things. So now for this other type, it is very, very easy for you to more like find things because it will have more like smaller number of rooms. So the fastest is what we call registers, which are found directly into the CPU. Then we have cache memory, which is the linkage between the RAM and. So here we have the registers, and then here we have what we are going to call cache. So we have this memory is also very fast, and it sits between the CPU and the main memory, the main RAM. It stores frequently used instructions and speeds up the process by reducing access time like that. So let's have an example. I'm pretty sure you have seen something like this. You have, let's say, Facebook, it's 278 MB. So this is made up of the storage and the cache. You will even see when you go into info of the app, you may see clear cache. So now, what this actually means is that you will find that, let's say you go on Play Store, you might download Facebook at, let's say, 11 MB. But as time goes on, you might find it has gained more like 278 MB. So this is as a result of the cache that the app has acquired. So now, when you just download Facebook, you will realize to say you will need to log in, add your name and all that, but you cannot constantly be doing that each time you more like access Facebook. So therefore, the computer stores frequently viewed apps so that it reduces the access time, so that when you just press on Facebook, it will just be able to open and not ask you to log in and all that. So this is very, very important. So it sits instead of you, when you press on Facebook, it goes to RAM, which is found outside, it needs to just pass through the cache, which acts as a link between the CPU and the RAM. This cache is smaller, so it more like retrieves information very fast, then it will be able to access it like that. So that is basically what cache is. So you will understand more for other videos on these concepts. Number 3, we have when the system runs out of RAM, it temporarily stores data on the hard drive in a special file to stimulate more RAM. This type of memory is slower and can reduce system performance if overused. So this type of memory is what we call virtual RAM. So now, just as I explained, so remember in our example, we might have something like this. We have let's say we have the hard drive. So this is the hard drive, which is very big. Let's say we have the RAM here. So in RAM, it is very easy for you to find what you are looking for, though there might be some compartments like that, but it's very easy, it's very easy for you to find what you are looking for. But in the hard drive, you will find that for something that is here, despite looking or having the same space, if you are coming from the other side, it will be very difficult for you to find it. So now, how this works is that you will find that you might enter from here, but may not find what you're looking for. So this is what happens when this compartment is full. The information is stored in the hard drive. Now the hard drive stores things that the RAM does not necessarily store. So now when it is stored in the hard drive, it will be very difficult for the information to be retrieved. This makes the computer's access time to be very, very slow. So that is the concept between virtual RAM. Things that are supposed to be in these compartments are stored in the hard drive. So since the hard drive is not RAM, it will now be called the virtual RAM, just to store something like that, which might be retrieved. If overused, your computer may be slow. So that is what we simply mean by that. Let's move on to our next problem. Number 4. This is the standard type of RAM used in most computers. It must be constantly refreshed while in use and loses data when power is off. So this type of RAM is what we call a dynamic random access memory. So we have the dynamic RAM. You might have seen these initials, DRAM. So this one is number 1, it is mostly used in most computers and it must be constantly refreshed while in use and loses data when power is off. So that is what we refer to that. So dynamic, you can just think of it as changing, so therefore it loses data. Now number 5, unlike 4, this type of RAM is number 1, faster and does not need refreshing. However, it is more expensive and typically used for specific applications like cache memory. So number 5, we have unlike 4, this type of memory is faster and does not need refreshing. However, it is more expensive and typically used in specific applications like cache memory. So remember, cache is faster than RAM. So now, this type of memory, we can call it the SRAM. In full, you can call it static. You can finish it in random access memory, RAM. So now, you can just think of it as number 1, it does not need refreshing, meaning to say it's stationary. So you can just remember like that and write static RAM like that. Let's look at our next problem. So that one is static RAM. The other acceptable answer is magnetic resistive RAM for this question. Like that, the magnetoresistive RAM. So yeah, we have the static RAM or this one. So I highly recommend the static RAM for this problem. Let's look at our next question. So for this one, Miss Polepole is back. We are told that Miss Polepole has also taken on a project to set up a computer network in a resident hall. The goal is to ensure that both wire and wireless connectivity for the students, secure remote access for the off-campus communication, and efficient data flow across multiple devices. She has selected 5 specific components to include in the network. Each component, each labeled as A, B, C, D, or E. Read the description carefully and identify each device or service by writing its correct name. So number 1, it says that A, this device allows students with laptops, smartphones, and tablets to connect to the network without using any physical cable. It sends and receives data over radio waves and is installed in the center of the resident hall to ensure full coverage. Device A is... So now, if we look at this carefully, number 1, this device allows students with laptops, smartphones, and tablets to connect to the network without using any physical cables. It sends, so without using any physical cables, meaning to say this one, number 1, is wireless. So without using any physical cables, it sends and receives data over radio waves and is installed in the center of the resident hall to ensure full coverage. Device A is, number 1, it's wireless. So this one is what we call wireless access point. So this is what we call WAP. So the word WAP, W-A-T. So now, let's go into the... just a reminder. Cache might be as small as 256 KB, like that. So KB, which is very, very small. So let's go to that. And also, emphasizing on the points, we might have the RAM of a computer is 24, but it is something like 72 GB RAM. When we add this 48, which should be extracted from the ROM, getting a portion, which is what we now call virtual RAM. Meaning to say the 48 is actually virtual RAM. This is the RAM that you will see, 48 GB expandable virtual memory, or should I say. So yeah, so we are just recapping some of the things before we answer our problem. So this is the SRAM, then we have the DRAM, like that, the dynamic, the static, like. Okay, so here we are where we wanted to be. So we have the wireless access point, the WAP. So this wireless access point might be connected to a router, so it is able to broadcast the signals that the router has to more like it is put at the center, so that a lot of devices can be able to more like benefit from these networks. It's more like it's a network amplifier, like that. It more like magnifies the network and all that. So that is the wireless access point. So in the moment you are told things like this device allows laptops, smartphones, and tablets to connect without cables using radio waves. Radio waves, in brackets they say Wi-Fi. We can have, it is usually placed centrally to provide full wireless coverage in the building. Then that is what we are going to call the wireless access point like that. So devices such as laptops are able to benefit from this. So this is what we mean. So it might be put at the center from the ISP, which is the internet service provider, to the router, from the router connected to the wireless provider. The wireless provider is now able to share to other devices, put on the central, so that other devices can be able to share like that. For number 2, this simple device receives incoming data from one device and broadcasts it to all other connected devices regardless of the intended recipient. It's cheap but not very efficient device. B is A, so the one that shares to all the computers connected regardless of the intended purpose is what we call the hub. So let's go into detail. So let's say we have, this is the hub. So let's say we have this signal. This signal is the incoming signal. So when the signal passes like that, so this is our hub. So the hub, what happens is that when it enters, this same signal is more like it is shown on all the screens. Now this is not very reliable, in the sense that there is no privacy. What if you just wanted someone using this computer to see? But the hub will be able to more like show to all the computers that are connected. So as long as we have that type where we have the computer showing to all parts that are connected, then that is what we call the hub, like that. So this is basically what the hub is. It shows the broadcasted message or transmission to all the computers connected regardless of the intended recipient. It might be that you just want to send to this person that is here, but it will be broadcasted to all the points. Let's look at our next question. For this one, we have our C. This component is responsible for directing traffic between the resident halls and internal internet and internal network and the internet. So immediately, internal network and the internet, think of the router. It ensures that outgoing and incoming data is correctly routed. That's where the name router is coming from, to and from external network. Device C is, this one is what we call the router. Let's get into detail. Okay, so to explain the router, we first need to understand the hub and the switch. Though we are not going to talk about the switch now, we are going to answer it later. So the hub, as you can see, it is only dealing with the computers that are connected like that. Now, what if we want an external computer to more like receive the same message? That is where the router comes into play. So as you can see, this is we might have the hub there. Then this is a router. We have the hub. We might have the hub like that. This could be a hub or a switch. So now, what we have is that, let's say, as we can see, we have the screen red. We also have the blue screen here. So we have the green screen, we have the yellow screen. So each screen is more like having a different connection in terms of they are not connected to the hub and all that, to one hub and all that. So therefore, what begins to happen is that, what if you want to broadcast a message to the internet? Remember, the internet is just the interconnection of computers. So this is where the router comes into play. So the router, when the message passes through the hub or the switch, it goes to the router. The router might, number one, retain the message there, or it can go to the other parts, and you will find that this yellow thing is coming from, number one, this yellow computer. Then this message can be taken to whichever place Now we also have the same message, same approach with other computers. They are able to send their messages to the internet, which is the interconnection of computers which are not more like connected like from one hub and all that. So this is very, very important. The router more like provides the route. This is what we mean. The router provides the route so that it is taken to the internet, more like other computers, for the information to be seen. The hub was just working under the local area like that, the computers that are just connected to it like that. But if he wants the message to be read by the internet, or rather by other computers that are not physically connected like that, you will have to use the router. So that is one thing that you need to know about the router. So this component is responsible for directing traffic between residence halls, internal network, and the internet. So, and the internet, it ensures that outgoing and incoming data is correctly routed to and from external network. Device C is the router. Let's look at our D. You should know that definition. Let's look at our D. This device is more advanced than B. It can analyze incoming data and forward it to the specific device it is meant for, improving both speed and security within the whole internal network. Device D is, as long as it is advanced and it is able to analyze incoming and forward it only to specific devices, this is now what we call a switch. So you can think of you switching the light. When you switch a light, a specific light will be able to more like be on like that. So the switch, how it works, it's like this. So this is our switch like that. So when a message is sent, it only goes to the intended, more like intended computer within the internal network. Unlike going to all parts, it's more efficient and it is more safe like that. It comes from here, goes there. But as for the hub, it could have been sent to all parts. So that is the answer there. So we have the switch is a device that is more advanced than B, and it analyzes incoming data and forwards it only to specific device. It is meant for improving both speed and security within the whole internal network. Device D is the switch. So it is able to do this through reading the computer's MAC address. So they will have MAC addresses like that. Then for E, we have, so if you are enjoying the content, kindly subscribe so that I can even be motivated to create more content like this. So we have our E, to help students who are off campus connect to the residence halls network securely. Mr. Pole Pole sets up the service that creates an encrypted tunnel for secure communication over the internet. Service E is this one. As long as we have encrypted tunnel, this one is what we call the virtual private network. Let me write it here. Virtual private network. Not virtual private network. So this is what we call VPN. So this one, just as we have said, it works in that way. So it encrypts and tunnels for secure communication over the internet. So the internet is not really safe for many things. You need a secure way of accessing the internet. This is where the virtual private network works. You might have used the VPN, maybe you are trying to just access free bundles and all that. Okay, let's get into details. Okay, just a recap. We have the router Here we have the local area network. It is able to transmit messages from the local area network to the internet, so it routes a way to get there so that these other clients can see even the messages and all that. So this is the wide area network, so the router is important for that. Yeah, so we have looked at the switch intended for the intended thing. We have the wireless access point, which more like enforces the Wi-Fi signals and all that, so that more computers can be able to access the information. Then let's look at what we are here for. So number one of the things that we have said about the VPN is that it creates more like a tunnel where the information can be able to pass freely, so that it is not accessed by other people on the internet. This makes it more secure, and also it encrypts the network like that. So this process is encrypting. Now let's look at it further. So we might have something like this. The computer signal passes through the VPN to access to more like go to the internet like that. Let's go. So when you're using your computer, there is the concept of IP address. So IP address is more like the actual address where you're using your computer. Now this information is found, let's say, on the internet. They access where you are. Some of the people, number one, there are people, let's say they want to kill you, they would know exactly where you are. So this is why the VPN is very, very important. You will find that the VPN in that area will more like look like that. You send a message, it passes through the VPN. What the internet will be able to show is the location of the VPN, which is far away. Now if they see the location of the VPN, they won't actually see your location like that. So as you can see, the numbers which entered were these. Enter through the VPN displays its IP address or the location. So now we can have the internet providers like that. So the hackers, they can even find your information like that. They can access your information as it is passing like that. The internet providers and all that. Then we have the government like that. So to prevent this, we have the VPN. It's more like creates data. It creates data to be more like encapsulated with an extra layer of protection like that, so that it's not easy for your data to be easily accessed like that. And also there is the aspect of tunneling like that. It passes through the tunnel so that it cannot be accessed by hackers and ISP like that. So it is very, very secure. Let's say you have been given, imagine you are working as a junior systems engineer at a telecom company. During system configuration, your supervisor hands you a few values from different devices and asks for quick conversions to ensure compatibility between systems. So the first question says, we've got a binary data packet coming as 1, so this value, but our monitor 2 only reads hexadecimal. What would that be in hexadecimal? So we have the number such as a 1 0, a 1 1 0 1 0 1 0 1 1 0 1 2 3 4 0 1. So we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Are we supposed to have 16? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So where's the surplus of numbers? 0 1 1 0 1 2 3 4 0. After 0 1 1 0 1 1 1 should be here. So we have 1 1 0 1. So now you want to convert to hexadecimal. So remember the number hexadecimal is 16. 2 to the power 4 is equal to 16, like that, meaning to say you need to split this into 4 parts. So you're going to have 4 parts like that, 4 parts like that. Okay, so 4 parts like that, 4 parts like that. Then here we are remaining with 2. That means to say we are going to add 2 zeros in front, then do the calculation individually. So we are just going to multiply the numbers. 2 to the power 0, like that. Then we have 2 to the power 1. So whatever you get, you multiply, then add. So we have 2 to the power 2, we have 2 to the power 3. So for all these, this is what we are going to do. So we have same here. So let's just space them a bit. So we can now have, is this our final one? Okay, so we can now have 4 parts. So we have this part, we have this part, we have this part. So just 4 parts, so these colors can distinguish. So we have 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 0. Then we have 2 to the power 0, 2 to the power 1, 2 to the power 0, or 2 to the power 2 and 2 to the power 3, like that. So here, even here, it's supposed to be 2 to the power 3. So that is how we do that. So we are going to now add in parts. So here we have an answer, we have an answer, we have an answer there. So 1 times 2 to the power 0 is 1. So it's 1 times 1, which will give us 1, plus 0 times whatever we have here is 0. 0 times anything is 0. 1 times 2 to the power 2. 2 to the power 2 is 4. So we are going to write plus 4. 1 times 2 to the power 3 is 8. So we are going to have plus 8, like that. We are here. 1 times 2 to the power 0. 2 to the power 0 is 1. So we are going to have 1 plus 0 times 2 to the power 2 is 0. Then, yeah. So we have 2 to the power 2 times 0. This will give us a, so I've skipped. So here we have a 2 to the power 1 is 2 times 1. It will be 2 plus 2 to the power 2 is 4 times 0 is 0. Then we have 2 to the power 3 is 8. So we are going to have plus our 8, like that. Then here we have 1 times 2 to the power 0 is 1 plus 2 to the power 1 times 0, it's 0. 1 times 2 to the power 2 is 4. So we are going to have a 4, like that. Then we have plus 2 to the power 3 is 8 times 0 is 0. Then here we have 1 times 2 to the power 1 is 1 plus 2 to the power 1 is 2 times 1 is 2. 2 to the power 0 is 0 plus 0. So we just add them now. So we have a 3. 2 plus 1 is 3. 4 plus 1 is 5. Then we have here 8 plus 2 plus 1, that's 11. Now if you remember, 10 is equal to A, 11 is equal to B, 12 is equal to C, 13 is equal to D, 14 is equal to A, B, C, D. So A, B, C, D, E, like that. Then we have F. So let's see if we need all these. 8 plus 4 is 12, plus that is 13. So 11 shall acquire the letter E. So we are going to bond the letter B here, not B, but 11. Yeah, 11 is B, so we attach B. 13 is D, so we attach D and put the base 16 here to show that it's in hexadecimal like that. For this one, we are told also I see an IP address listed as 255. So we have 255, 127, 0, and 71 in decimal places. We need to push it to hardware that processes only binary. Can you convert for me as a 32-bit? So for this one, 32 bits means you should have 32 digits. Meaning to say, for each number, if you have 255, you should have 8 numbers. 8 numbers, 8 numbers, 8 numbers. If you add 8 plus 8 plus 8 plus 8, you are going to get 32 digits, which is a 32 bits like that. So now, to convert this, there are two ways, but let's use the easiest way. So this easiest way, what we are going to have is this. So we are going to write the powers of 2, which are 2 to the power 0 is 1. So we are going to write 1. We are going to write 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. So from here we can just 32. 32 plus 32 is 64. 64 plus 64 is 128. 128 plus 128 is 256. So for this method, what you're just going to do is that for each and every number that you're going to use, you're going to put a 1. So if I add my 1, plus 2 plus 3 plus 4 plus 16 plus 32 plus 64 plus 28, I'm going to get a 255. Let's verify this. So we are going to have our 1 plus 2 is 3 plus 4 is 7 plus 8 is 15. 15 plus 31, 15 plus 16, that's 31. 31 plus this 32, we are going to get a 363. 63 plus a 64, we are going to get a value that is equivalent to 127. 127 plus 128, we are going to get 5 here, remainder 1. 2 plus 2 is 4, plus 1, that's 5. 1 plus 1 is a 255. So as long as those values that I've used, I'll put 1s like that. So this value is 1, 1, 1, 1, 1, 1, 1, and 1 like that. So it has been converted. So same approach with 127. So getting 127, we are going to use these same values. We have 1, 2, 4, 16, 32, 64, and 128 like that. Then we have a, so mainly we are not going to exceed the value by much. So we are going to have, so here I can get 1 plus 2 plus 3 plus 4 plus this plus this plus this. So remember, when we added this, we got 127. So 1 plus this is 3 plus 4 is 7 plus our 8. So we have skipped 8. So we have 1, 2, 4, 8. So plus our 8, we are going to have 15 plus that is 31 plus 32 is 63. 63 plus 64, that's 127. So for all the values, I've used all these values. So I'm going to put a 1, 1, 1, 1, 1, 1, 1 like that. So now this is what we have. Now remember, we are supposed to have 32 bits, meaning to say for each number we should have 32, or we should have 8. We have 1 2 3 4 5 6 7 8, like that. So even here we should have 1 2 3 4 5 6 7. So put the 0 at the end here, then take the number from here up to here. So 127 is equal to, begin with the 0, then we have 1 2 3 4 5 6 7, like that. So this is the number expressed in that form. Then we are going to convert the 0. So converting the 0, we are going to have 0, just put 0 is equal to 0 0 0 0, 8 of them, like that. 1 2 3 4 5 6 7, like that. 8. So this is what we have for 0. Let's look at our last part which we need to convert, which is our 71. So 71, taking the same approach, 1 2 4 8 16 32 and 64, like that. So to get to 71, the numbers that we can use are 64. So where 64 is, put a 1. So we can't use 32 because that will be over 71. We can't use 16, we can't use 8. So meaning to say we have to use a 4, we have to use a 1, we have to use a 1. 7 plus 64 will give you 71. Then where there is space, put zeros, like that. Then what we have is 1 2 3 4 5 6 7. So you're going to put the 0 there, and you are going to have a value that is equivalent to taking the value going this side. You are going to have 71 is equal to 0 1 1 2 3 1 1 1. So this is the number that we have. So to just write it properly, 255.127.0.71, to display it like that. 255 is equal to 1 2 3 4 5 6 7 8 points. 127 was found to be equal to 0 and 7 ones. 1 2 3 4 5 6 7. We have point, another one. We are going to get 7 zeros, like that. 8 zeros, sorry. 1 2 3 4 5 6 7 8. And for 71 we are going to get so the value is a space, a 0 1 1 2 3 1 1 1. So like that. So this is what we have for that problem. To answer the last one, so the last one of our order 2s gave a memory address as 745 in octo, but we need it logged in hexadecimal. Can you make that conversion too? So for this one, we have the 745 octo. So what we are going to do is, let's convert this one to decimal, meaning to say to base 10. So how we do that is by doing this. So you can watch the video on the conversion for further analysis. So we are going to have, since it's 8, we are going to have powers of 8, 8 to the power 0, 8 to the power 1, 8 to the power 2. Then we are going to add them. So we have 8 to the power 1 times 8 to the power 1 times 5 is equal to a 5 plus 8 to the power 1 is 8 times 4. So we have here, we had a 1 times 5, 8 to the power 0 is 1. Then here we have 8 times the 4, which will give us a 32. So this is how we convert to base 10. Then here we have a 8 to the power 2, which is equal to a 64. Then 64, we multiply it by 64, we multiply it by 7, and our 64 by 7 will give us a value. So we have a 28, remainder 2, 7 by this is 48, plus 2, that will give us a 44, like that. So we are going to have plus our 44 when we 448. When we add these, we are going to get a 485. So this is in base 10, though we don't write this, but it's in base 10. From here, converts to hexadecimal, meaning to say you get this value, divide by that base. So we are going to have something like this, and so we are going to have something like this. We have 485 and we have a 16. So we are going to divide 485 divided by 16. 48 divided by 16 is 3. 5 divided by 16 is, it can, so it's going to be 0 point, remainder is 5. So we are going to have a 30, remainder 5. 16 divided by 30 is equivalent to 1. Then the remainder will be 14. The remaining number is 14, because 14 minus plus 16 will give you a 30. Then we are 1 divided by 16 is 0. Then our remainder is 1. Now 14 is equal to, if 10 is equal to A, 11 is equal to B, 12 is equal to C, 13 is equal to D, and 14 is equal to E. So meaning to say, where there is 14, you are going to put the letter E like that. So taking the values like that, we are going to find that our value for that one is equal to 1E5, which is in base 16 like that. So this is how we answer that one. Okay, let's look at the multiple choice. We have carefully examine the following multiple choice. Circle the answer. So which one of the following is an example of a non-contact, non-impact printer? So the best answer among these is the laser printer. So the laser printer uses a laser to scan and do that. Then we are here, which of the following is not a wireless network? So let's look at this. Bluetooth is wireless, Wi-Fi is wireless, you don't need a wire. LET, which is data, is wireless. Ethernet is a cable, so a cable which connects. So when we were looking at the hub or the switch, it was connected by to a computer by a cable. That is what we call the Ethernet. So this one is not a wireless network standard. We are here. What type of a storage device is USB drive? So USB flash drives use the solid state drive. If you recall what I said about the solid state, or it's the only difference is that the flash drives are usually smaller than the solid state drives. So that one is a solid state drive. It is not a magnetic, it's not a cloud based, it is not optic like that. So it is a solid state. So I remember a SSD, that's how flash drives are also created in such a manner. They are solid state. So which of the following is not a valid IP4 address? So when we are looking at IPv4, this takes values from 0 to 255. So if it is outside this range, then it's not valid. So we have the 0 to 255 like that. So let's look at these options. So whatever is above 255 is invalid. So this one is not valid like that. Our 5, which of the following is not a touch screen gesture? So a touch screen, you can pinch, you can tap, you can swipe. However, you cannot click. It's not a computer, like it doesn't have a mouse, so you can't click. Number 6, which type of cloud computing service provides virtualized computing resources over the internet? So we have, for this one, the answer is ISS, which is infrastructure as a service. So we have infrastructure as a service, so which is our ISS. So this one is responsible for providing virtualized computing resources. It is the one that is responsible like for servers which are able to aid in the communication. It is also important for some storage and networking and all that. Then we have, when you look at the storage as a service, we have STAAS, that's storage as a service. We have SAAS, that's software as a service. We have PAA, that's platform as a service. So just as the name entails, platform as a service is responsible for providing a platform for where developers can build and test or deploy applications. What we mean by that is just testing. Let's say someone creates an application, they can create an application on PAS, which is platform as a service. On the other hand, for the SAA, that's software as a service, this one is responsible for making ready or for providing ready to use software application over the internet. The examples of software as a service, we might have Gmail, we might have Microsoft 365, which is Microsoft having everything. We might have a Zoom, or we might have a Dropbox, like that. So we might also have this one, which is used for storing of files, which is our storage as a service. We might have some things like Google Docs, not Google Docs, we have Google Drive, we have Dropbox, we have OneDrive. So those are used as storage as a service, like that. So for this one, the one that is important for providing virtualized computing resources over the internet is what we call the ISS, which is IaaS, which is infrastructure as a service, like that. Let's look at number 7. Which of the following is not an example of a cloud storage service? Which of the following is not an example of a cloud storage service? So remember, we have already talked about the Google Drive, we have the OneDrive, we have the Dropbox. These are actual cloud storage services. However, the Cloud9 is not. Let's look at our next question. Which type of cache mapping method allows multiple cache blocks to map to the same location? So for question 8, looking at the fact that the type of cache mapping method allows multiple cache blocks to map to the same location, this one is fully associative, meaning to say many can be able to. Associative means to say they can be mapped to the same location. Generally they can be mapped to the same location, but for other things such as direct mapping, it means to say it can only go to one specific location. If another one comes here, it will be able to more like displace. It will be able to more like displace the other, like that, displacing it, thereby moving it out of there. So that is what we mean by the direct. But if we are looking at the one that deals with multiple cache blocks to map to the same location, this is fully associative, like that. Then for sequential, this one is not more like the official term. Then the set associative, this one is an hybrid between the two, but for this one you can watch other videos to explain more on this, but for this one it's fully associative. Number 9, the bus width bus width determines the speed at which data travels and is also referred to as the. So for this one, the width determines the speed at which the data travels and is referred to as the. So this is what we call the word size. The word size, the bus width is more like the number of bits that can be transferred between the CPU and the memory. It's more like the number of, you can think of it as the number of lanes that are going to the CPU and the number of information that can be exchanged from the CPU going back, like that. So this is what we call the word size. If you want more in details, you can watch another video. So for number 10, we have which of the following protocols is used for secure web communication. Question 10, which of the following protocols is used for secure? So immediately you see secure web communication. The answer is the HTTPS, which is the hypertext transfer protocol, like that. Secure at the end. So we have, this means hypertext transfer protocol secure. So this one is responsible for more like a secure web communication. This POP is used receiving email like messages from email. So we have the FTP. This one is used for file transfer. So file transfer protocol. We have the IP. This one is generally used for communication on the internet. So this one is used for overall internet communication, but it's not secure. So the word secure, we have the HTTP there. So the IP address and all that, these are used on the internet communication. But for secure communication, we use the HTTP. Okay, so we have carefully examined 10 statements. Only 3 of them are true. Which ones are they? Your answer will not be marked if you indicate more than 3. So let's say we have all manual input devices must be physically connected to the computer. Already this statement is false. Other input devices that we might have is even Bluetooth. You don't need to connect. Bluetooth is an input device. We might also have a wireless mouse. Wireless mouse is also an input device. So some input devices you don't need to connect. Optic mice use laser technology to detect movement. This is false. Optic mice use LED, which we talked about. That's the type of light. Then the one that uses laser technology is laser mice. Then for number 3, a solid state drive is more durable than hard disk drive because it has no moving parts. This one is true. So just as we said, solid state meaning stationary, and it's more durable. Number 4, flash drives and SSDs both have solid state technology, but SSD typically offers more storage. This one, as I have said, is true. Then when we have 5, increasing RAM always improves a computer's performance regardless of the number of running application. This one is false. You can tell that sometimes, let's say the Techno phones in comparison with the Samsung, you will find that a Techno phone sometimes might be 4 GB, might be 8 GB, but a Samsung phone might be let's say 4 GB, but a Samsung phone sometimes might perform better. So it depends on the architecture, the make, and all that. So this one is not always true. So let's look at our our number 6, DSM, DSL, and cable modems transmit data using different types of physical wiring. This one is true. So as you can see, these are the cables. We have this one, this one is using this type of a cable. This one is called the coax cable, which you have seen like on your coax cable. You have seen it on DSTV or on GoTV, so you can tell by this thing. So this is a coax cable. Then DSL uses this type of a cable, so they use different cables. Now for number 7, morphing is a special effect that instantly changes one image into another. This one is false. So instantly meaning to say it just happens there and then. No, it is a gradual process. So what I like to think about on this one is just Power Rangers, those people morph and they take time. You can just remember it by that. Morphing is a gradual change of an image into another. Then the near field communication, NFC, requires internet access to transfer data between devices. No, the word internet excludes the answer. You don't need the internet for you to more like transfer files using near field communication. So this one, just as the word entails near field, and the internet is a global, so you can just think of that near field, meaning to say it just uses radio waves at a near distance to send files or items. Then we have a processor with 2 cores will always be twice as fast as a processor with 1 core. So already always is not true, because number 1, processors cores are different. 1 core might be 8, another core might be 2 cores, having each core is having, let's say, 2 and 2. 2 and 2 is just 4. So it's not always that as long as it has got 2 cores it will be faster. No, it the makeup depends on the clock speed, which is the speed at which number of cycles a processor can execute per second. More like the number of instructions the processor can be able to process in a given second. That's clock speed. So to understand more about how cores work, it's more like if you have 2 cores, it simply means to say you can think of 1 and 1. 1 plus 1 is 2 cores. 1 core, one of them is playing music, the other one is let's say cooking. So this is how cores work. So they are more like multitasking. Now 1 core might just be performing 1 task at a time. Now the idea is that a processor with 2 cores will always be twice as fast with 1 core. Not really. There are some applications, or rather some executions, that only require 1 core, meaning to say only 1 core can do that job. Like for example, let's put it in human analogy. Let's say 2 people are trying to more like knit. Now you need to more like put the cotton inside the eye of a needle. Now for that task you only need 1 person to be able to do that. Now yes, you might be the 2 of you, but only 1 person is needed for that. So that means to say even a computer with 1 core can do that same task at the same time like that. So it is not always that a computer with 2 cores will be faster in that idea. So a processor with 2 cores will always be faster, will always be twice as fast as a processor with 1 core. So it doesn't work like that always, but sometimes it does. But the key word is always. which is not true. The last one, turning off wireless devices when not in use can reduce e-waste. So e-waste, which is electronic waste, has to do with the disposal of hardware. Turning off wireless devices only saves the battery. So that is not e-waste. That's not reducing e-waste. So meaning to say this statement is false. So e-waste has to do with the disposal of hardware. So the correct answers we have is a 3, 4, and number 6. So these are the three answers, number 3, 4, and 6. So that's it for your CS110 test 1. Thank you very much for watching. Hope you would like, subscribe, and share for more, so that I can even be motivated to create more content for you like this. See you in the next tutorial. Comment for whatever you want in biology, chemistry, math, physics, and CS110. See you in the next tutorial.